Hi, a technician is working on an electrical circuit, and his screen is giving him this graph. And this graph, the coordinates of this graph are current and time. And for his report, he wants to be able to include a mathematical expression between the coordinate system. So this is a good example. This is a very good example on how to write the expression for a graph like this. The general form of a formula for a graph like that, it can be written as IT is equal to A multiplied by e to power minus AT. So anytime your graph looks like that, you can use this formula. And where A is the amplitude of the curve, and small a is the constant. So in order for us to express this curve, this graph, in a mathematical expression, we have to find the values for A and small a. So let's, and we can do that by the information that the graph is giving us. So let's say at time zero, we can write this formula as our current at time zero is equal to 6 times 10 to power minus 3, which is equal to A times e to power minus A multiplied by 0. This is 4 times 0. So e to power 0 is equal to 1. So from here, we can see that the value for A will be equal to 6 times 10 to power minus 3. Now we have to find the value for this small a. So for that, let's use at the second point that the graph is giving us. When our time is 2 times 10 to power minus 3, our current is also 2 times 10 to power minus 3. So our current, when the time is 2 times 10 to power minus 3, is equal to A times e to power minus A times 2 times 10 to power minus 3, and that is equal to 2 times 10 to power minus 3. Our current at 2 times 10 to power minus 3 is equal to 2 times 10 to power minus 3. So here we already have found the value for the amplitude, which is 6 times 10 to power minus 3. So let's go ahead and plug that here. So we are going to have 6 times 10 to power minus 3 multiplied by e to power minus A multiplied by 2 times 10 to power minus 3 is equal to 2 times 10 to power minus 3. Now we have one equation with only one unknown, that's the small a, and that's what we need to find. Once we find that, we can plug it in, we can plug the values for a and the small a in this formula, then we will have a general expression for this curve. So from here, let's go simplify that. On both sides of this equation, 10 to power minus 3 will cancel out. Also, we can simplify this. 2 divided by 2 is 1, 6 divided by 2 is 3. So we are going to have 3 e to power minus a times 2 times 10 to power minus 3 is equal to 1. Now, in order to solve for a, let's go ahead and take the natural log of both sides of this equation. So here we are going to have natural log of 3 times e to power minus a times 2 times 10 to power minus 3 is equal to natural log of 1. Which natural log of 1 is equal to 0? Which is equal to 0. Now we can use the natural log formula. We know that natural log of a multiplied by b is equal to natural log of a plus natural log of b. So using that formula, we can simplify this as, as natural log of 3 plus natural log of e to power minus a times 2 times 10 to power minus 3, which is equal to 0. Now we want to solve this for a. We can use the formula. The formula natural log of e to power x is equal to x. So using that formula, we can simplify this, and we can write this as natural log of 3 minus a times 2 times 10 to power minus 3 equal to 0. Or we can write this as minus a 2 times 10 to power minus 3 equal to minus natural log of 3. So the minus will cancel out on both sides. So here a will be equal to natural log of 3 divided by 2 times 10 to power minus 3. So this will be equal to 550. Natural log of 3 divided by 2 times 10 to power minus 3 will be 550. And since they are writing everything in this form, so instead of 550, let's put 0.55 times 10 to power 3. So our a is 0.55 times 10 to power 3. So now the general form, the general expression for this curve is it is equal to 6 times 10 to power minus 3 multiplied by e to power 0.55 minus 0.55 times 10 to power 3t. So this is the mathematical expression for this curve, and so this is what you should include in your report. Thanks.